We've spent quite a bit of time talking about solving quadratic equations. In this section, we're going to talk about solving quadratic inequalities. You might want to go back and review linear inequalities a little bit, just for a reminder, in particular about the interval notation. We'll be using that in this section. All right, so first we're going to talk about solving graphically. Using the graph below, solve x squared minus 2x minus 3 less than 0. So here's our x squared minus 2x minus 3, and it's less than 0 means that it's below the axis. If I said bigger than 0, it would be above the axis. So where is it below the axis? Well, it hits the axis right there, and it hits it again right there, and it's below through all that part. So that looks like it starts at -1 and ends at 3. So we would write our answer as that in terms of an inequality, or we could write it in interval notation like that, and we get round brackets because we don't have any equal to's. So notice when you solve, in this case, we get one solid chunk of the graph in the middle, and we get one answer in a sense. Let's compare that to this one. Solve x squared minus 3x minus 8 greater than or equal to x minus 4. All right, so the x squared minus 3x minus 8, that's the blue curve, and the x minus 4 is our red line. First off, where are they equal? They're equal right here where they cross. And then we want the blue one to be bigger than the red one. Bigger than means higher. So we want that part. The blue is above the red there. We don't want any of this part because the blue is below. And then we want this part. So notice what happens here. We have two distinct different pieces shaded. When that happens, you have to write two distinct answers. This one starts at -2, and then the x's get smaller. So that would be x less than or equal to -2. And then this one starts at 6, and the x's get bigger. So this would be x greater than or equal to 6. And in interval notation, we could write this way, minus infinity to -2. -2 gets a square bracket because it does have the dot. Infinity and negative infinity always get round brackets. And then you'll typically see that symbol for or union. And then we'll have 6 to infinity. And again, 6 gets a square bracket because it has the dot. Infinity always gets a round. All right, the thing to notice with these two answers is that we get two different types of answers for these problems. Sometimes we get one answer where x is stuck in between two numbers, and sometimes we get what really looks like two different answers where x starts someplace and goes to the left, and x starts someplace and goes to the right. So we'll keep that in mind as we solve algebraically. So now let's look at solving algebraically. To solve quadratic inequalities, you do it very much like you do a quadratic equation. If this were an equation, the first thing I would say is, all right, we notice it has an x squared. The next thing I would say is we got to have 0 on one side. We already have all that. So now we factor. This one factors as x minus 3 and x plus 1 less than 0. Then I'll see students do something wrong. All right, so I'm going to write wrong here, and I don't want you to do this. X minus 3 less than 0, x plus 1 less than 0. And the reason this is wrong is look what we end up with. We end up with x less than 3 and x less than -1. But look at the answer. This is the same problem we did before. Here, when I did it wrong, I end up with x less than -1, but x should really be bigger than -1. X started at -1 and went to the right till we got to 3. Okay, so the right way to do this is this. You solve like it's an equation. You write x minus 3 equals 0, x plus 1 equals 0. You get x equals 3, x equals -1. what you're going to do next is you're going to draw yourself a number line. And you're going to mark -1 and 3. Back in my original problem, I just have a less than. I do not have an equal to, so both of these get circles. What we have done is we've split the number line into 3 regions. The region bigger than 3, the region between -1 and 3, and the region smaller than -1. What we're going to do is we're going to pick a number in each region and test it to see if it works in the original inequality. If a number bigger than 3 works, and it doesn't matter which number you pick, if any number bigger than 3 works, then all of them work. If you pick a number bigger than 3 and it doesn't work, then none of these numbers are going to work. So let's pick our favorite number bigger than 3. I would probably go with 4. I'm going to plug 4 in. If I plug 4 in, I get 16 minus 8 minus 3. Well, that's 5. Is that less than 0? No, it's not less than 0. Since 4 didn't work, no number up there is going to work. I come to my next region. I pick my favorite number in the middle. I would definitely pick 0. I always pick 0 when I can because it's a very easy number to use. When I plug in 0, I get 0 minus 3. Is minus 3 less than 0? The answer is yes. Since 0 worked, any number in there is going to work. Finally, I pick my favorite number smaller than -1. Probably -2. -2 squared is 4. And -2 times -2 is 4. Minus 3, I end up with 5. Coincidence that I got the same number. That's okay. Is 5 less than 0? The answer, once again, is no. So here is our correct answer. Our correct answer is -1 less than x less than 3. Written in interval notation, -1 to 3. And notice, now we have the same answer we got last time. Okay, let's try problem number 2 algebraically. Again, we already did it graphically. We already know the answer. Let's try it algebraically. First thing I would tell you is you have an x squared. If you have an x squared, you have to have 0 on one side. So we got to move these over. X squared minus 4x minus 12 greater than or equal to 0. Next we factor. X minus 6 and x plus 2 greater than or equal to 0. Now again, what you need to do at this point is solve like it's an equation. So we write x minus 6 equals 0 and x plus 2 equals 0. That gives us x is 6, x is -2. Draw your number line. And again, it doesn't have to be a fancy number line. I'm only going to mark 2 points, -2 and 6. This time my original problem has the equal to, so this time I put dots. Once again, I've divided my interval into 3 regions. Bigger than 6, in the middle, and smaller than -2. My favorite number bigger than 6 is 7. Now I'm going to show you a little thing that I would do is I would not take 7 and plug it into the original because it's kind of hard. What I'm going to do instead is I'm going to take 7 and plug it in down here in my factored form. 7 minus 6 is 1. 7 plus 2 is 9. 1 times 9 is 9. Is 9 bigger than or equal to 0? Yes. So since 7 worked, any number up here is going to work. X equals 0. If I plug 0 in, I get -6 times 2. That's -12. Is -12 bigger than 0? No. So we cross it off. Finally, favorite number smaller than -2. How about, just to be different, how about x equals -5? You probably pick -3, but like I said, just to be different. All right, so plug in -5. I'm going to have -5 minus 6. That's -11 times -5 plus 2 is -3. Well, negative 11 times negative 3, when I multiply two negatives, I get a positive. Happens to be 33 in this case. 33 bigger than 0? You bet. Okay, so notice our answer, again, is similar to what we did when we did it by graphing. We have two separate pieces shaded. Here, when we did it by graphing, we had two separate pieces shaded. When we have two separate pieces, you have to write two separate answers. And so our answer, once again, would be x less than or equal to negative 2, or x is greater than or equal to 6. And if you're asked to write it in interval notation, it would look like just like it did last time. Okay, going to take a little pause, let you think about those for a minute, and then we'll move on. We have a few more questions in this section.